Hello guys, my name is Annelise Msweli and I'll be doing hypothesis testing for the mean. So the exercise is in page 124, exercise 7.2. It reads as follows. A certain toothpaste brand has over a period of years received a mean rating of 5.9 on a 7-point scale for overall customer satisfaction for their product. Because of a minor unadvertised change in the product, there is a concern that the customer satisfaction may have changed. Suppose the satisfaction ratings from a sample of 60 customers have a mean of 5.6 and a standard deviation of 0.87. So what we must note in this questioning is that there is a sample, so that it means you use X bar, and also the standard deviation is given from the sample, and also the mean that is given at the beginning, it's from a population.
Yes.
Yeah. So that's the emphasis. So you first write what you have. Our X bar, we said, is 5.6 and the population mean is 5.9 and the standard deviation is 0.87. Then we continue with the question, and our n is 60. Do these data indicate that the mean satisfaction rating is different from 5.9? Test with a significance difference of 0.05. So we must note the questioning. So the question says, do these data indicate that the mean satisfaction rating is different from? So different, there's no more than or less than. So it means that it's a two-tailed test. Yeah. We do our step 1, which is hypothesis. So H naught, say like our mu did not change, which means it's that 5.9, and then hypothesis 1 means our mu did change. And then we move to the step 2, which is our test statistic, which is basically our formula. Okay, so the formula that we'll use here is T distribution. It's a T, because we'll be using a standard deviation from the sample. So if you are given a standard deviation from the population, so you will use this sign, the formula that has the sigma, But in this case, you have E standard deviation from E sample, and then we move to step 3, which is our rejection region. So that's where we'll state when we reject OH naught. And this, since this is a two-tailed, so we must first draw so that we see. It's a two-tailed, so which means that it's either it's less than or more than, right? So we reject OH naught if OT observed is greater than OT n-1, and then O alpha divided by 2. So the reason why I'm saying alpha divided by 2 is because here it's O alpha, this space is 1 minus O alpha, and here O alpha is divided in 2 since it's a two-tailed, right? And or you reject to H naught if OT observed is less than OT, and then like this n minus 1, you have to put your n is actually 60, then minus 1, and then it's going to be 59, and then your alpha is 0,05. Okay, let me write it down here. Your alpha is 0,05, so your alpha divided by 2 is 0,025. Yeah. So that's what you write down here. So 59 and 0,025. Can you look for the O2 59 0,025 in the table?
It's two.
Two.
Yeah. We're using 60 since 59 is not there.
Oh, okay. So since if you look at the table, we'll be using table 3, the T distribution table. So there you'll find O40 and O60, right? So you just, if O59 is closer to O60, so that's why you choose to use E values for O60, because 59 is closer to O60. And then we said this is a two-tailed, so we say or if OT observed is less than T, 59 0,025 is equal to 2. Yeah, and then we move to the next step, which is the calculation. We are calculating now. So we substitute from your formula in step 2. Okay, so T is equal to your x bar. We look, x bar was 5.6 minus your mu, which is 5.9, divided by standard deviation, which was 0,87, and then your n is 60. Can you please put the numbers in the calculator? Negative 2.6710. I'm just going to round off to the nearest two digits in 2 decimal places. Okay, so step 4, we're doing the calculation and we got a negative answer. So if you got a negative answer, you take the less than, because it's negative, yeah. So that's what we're going to carry over to the next step, which is step 5, finding the p-value. Okay, so when finding the p-value, this thing it's a two-tailed. It's two-tailed, so which means that in front of your p-value, you're going to put O2 when you're like denoting it here. P, and then T. We said we'll take this less than, less than our t observed. So here you put a 2 because it's a two-tailed. And then our t observed is negative 2,67. Ne? And then, since it's a negative, you cannot find negative values on your table. Then you have to change it. And also, your t in your table is always greater than. It's not like less than. You cannot find less than. So you have to change it also. So, it's going to be greater than 2,67. You can also show it in the table, in the drawing, ne? Okay, since you found negative 2,67, which is on the negatives, it can also be on the positives. 2,67, like a positive 2,67, and the area going this side is equal to the area going to that side. So that's why it's also the same thing if you write it like this. So we're continuing. You divide by 2 because we want this section and not the 2 one. Okay. So divide by 2 and then divide by 2. So P is greater than 2,67. Yeah, can you look for me this number in the table?
What's the value?
We're looking for
2,67. 60 degrees of freedom, eh?
Yeah. But it's actually going to be 59.
Yeah, but you don't have 59, so it's 60.
Oh, yeah.
So it's on the edge. It's not in between anything, eh?
Yeah.
It's on the far right.
Yeah, so I use
yeah. Oh, you went to the extended table?
Yeah.
Oh, I see. But wait. Oh, yeah, we can do that. 16, eh?
Yeah.
2,67.
Yeah.
So it's between 2,66.
Okay.
2,66. You start with 2,7. So t greater than 2,7. And then 6 on the other side. No?
Yeah. Oh, okay. So I'm going to explain the part for the table, because it's kind of confusing. So we've got table 3, in which you look for our degrees of freedom. Degrees of freedom, and also like your T, it's actually a T distribution table. And then there's also the upper one. So if you can't find a number or a certain degree of freedom on your other table, then you could look on the other extended table. So that other table has like smaller probabilities. So we found 2,67, which was like has a degree of freedom which was 59 from the upper table. So you just write the numbers from your table, which were 2,7, and from the largest, so the smallest here, because if you go back to probabilities, the probabilities are actually going to be smaller. So the probability for 2,7 was 0,0005, right?
Mm-hmm. Yeah.
And you still write that P 2,67. Yeah, and then this one 0,005. Yeah. Oh, okay. And then still remember, ne? Here we divided by O2, ne? So we must bring it back now because what do we want? We want OP value in it. Yeah, so you want to bring it back now. 1/2 P value. So it's 1/2, ne? You times by 2 this side, and you also times by 2 this side. So it's going to be 0,009, and then your P value is going to be between these numbers. Yeah. So previously, ne, our P value, not the P value, the significance, which was your alpha, was U0. Your alpha was U0,05, and now your P value is between U0,009 and U0,01. So which means that your P value is actually smaller than your alpha. Ne? So we reject. Okay, so now we're going to our decision. Ne? This is our last step. Okay, so since UT observed, we took the less than. Since UT observed is less than UT 59 0,025 is equal to U2, and our P value is it's less than, oh yeah, no, let me write this thing here so that you see clearly. Yeah. And OP value is less than O alpha. We reject OH naught. So if we're rejecting OH naught, that means that we were more like accepting OH1. We're saying, okay, there is a change. Yeah. So we reject OH naught and conclude that we have sufficient evidence. So if we reject, we have insufficient evidence to say, no, this one is wrong. But if we failed to reject, then you would have said that there is insufficient evidence. Because in a case whereby we have to accept, you can't like exactly say you accept. You have to do many other hypotheses in order for you to be confident enough, to say you have insufficient. Sufficient evidence. Yeah. So we have insufficient evidence, and then we go back to look at the question. So the question was saying that, do these data indicate that the mean satisfaction rating is different from 5.9? So we're saying that we have insufficient energy to say that we have
energy. Sufficient energy.
Energy. Okay. We have sufficient satisfaction. We have
evidence. It's 10 p.m.
Okay. Okay, we have sufficient evidence. Okay, to say that there's E difference in customer satisfaction. Yeah. And that's it.